In Chapter 2, Section 4, we're going to start to review, we're going to start by reviewing properties of algebra, and then we're going to start to justify steps in solving an algebraic equation, which is going to help us to kind of introduce the idea of writing proofs. So now we're going to review the properties of equality, but I'm going to make a few corrections to this slide, especially for the addition and subtraction. But basically, properties of equality deal with real numbers. And because we're dealing with, in geometry, segment lengths and angle measures, which are real numbers, we're going to be able to apply some of these properties of equality to those types of problems as well, okay? But here, in addition property of equality, I want you to keep if A equals B, but we're going to get rid of this part and C equals D, okay? What we're going to do is change it for that. So what we're going to say is that if A equals B, then A plus C equals B plus C. And what we're trying to say in this property is that if A and B are the same, if I add a value to A on the left side, I add C, let's say, as long as I add C to the right side, my equation will stay balanced. The left side of my equation will still equal the right side of the equation. And so let me give you an example. Let's say 4 equals 4. We're at, right? 4 equals 4. And then let's make our C 2. If I do 4 plus 2 on the left and I do 4 plus 2 on the right, notice that even though the values are different, 6 equals 6, it's different than 4 equals 4, but notice that my equation stays balanced. So if I start with an equation where the left and the right side are equal, as long as I add the same thing to both sides, it's going to continue to be equal and it's going to continue to be balanced, okay? Now, the subtraction property is going to be of the same idea, okay? So again, let me do that. So I'm going to make a change to the subtraction one too, and I'm going to say again, if A equals B, I'm going to cancel this part out and C equals D, we don't want that, then A minus C is equal to B minus C. And again, this is that same concept. So again, let's make A and B both 4. So A equals B, which means 4 equals 4. And if I subtract the same value from both sides, like let's say I'll make C equal to 3. 4 minus 3 equals 4 minus 3. And notice that my equation stays balanced. Again, my values are different. Notice I start out with 4 equals 4 and I end up with 1 equals 1. Yes, if I add 2 to both sides or I subtract 3 from both sides, my numbers are going to change, but my equation will be balanced. My left side will equal my right side, okay? Now, once we get to our multiplication property and our division property, these notes are fine the way they are. So basically, in the multiplication property, again, we're starting out with the fact that A equals B. And it says that if A equals B, then A times C is going to equal B times C. And there's a restriction here that C cannot equal 0. And we'll get into that a little bit more in the future. But right now, let's just kind of talk about that. So again, if we have A equals B, let's say A is 4 and B is 4. And if I make C, let's say 10, then I know, sorry, I'm supposed to put 4 here. If I make C 10, then I know that 4 times 10 on the left is going to equal 4 times 10 on the right. And notice that 40 does equal 40. So again, my equation is balanced as long as I multiply the same thing to both sides. Okay, so you're seeing the pattern here, and what the pattern is that whatever it is that I'm going to, for example, in the addition property, whatever I'm going to add to one side, I have to add to the other. In the subtraction property, whatever I'm going to subtract from one side, I need to subtract from the other. In multiplication, whatever I'm going to multiply to the one side needs to be multiplied to the other. And in division, now that we know the pattern, right, we know that whatever I'm going to divide the one side by, I have to divide the other side by that same number. And again, yes, in multiplication and division, there is a little bit of a restriction that the number that I multiply or the number that I divide by cannot be 0. And again, we'll get into that as we go. But that's those are the properties of equality. And so here's some more properties of equality that are a little bit less mathematical. In other words, you're not adding, subtracting, multiplying, or dividing by the same number, but these properties are equally important. One of them is really important. I mean, they're all really important, but I like the substitution property. And basically what the substitution property states, right, is that if you start out with an equation, A equals B, you're basically being told that the value of A is the same as the value of B. And so what happens is substitution property tells you that you can then use either A or B anytime for the other one in an equation. So for example, if I know that A equals B and I have an equation that says 2A equals 10, I can use the substitution property to substitute in B for A. So I can rewrite this as 2 times B, or 2B equals 10. I can sub in B for A, because again, I can swap them because they have equal value. That's what I've been given. And so as soon as you know that something is equal to something else, you can sub it in anytime you want for that other value. The reflexive property, this one's kind of obvious. It's always silly to me. This one, it basically says that A equals A. In other words, anything that you put on the left equals itself on the right. So it could be, it doesn't have to just be a single thing. It could be like A times B equals A times B, or 2A equals 2A. So in other words, you're just basically saying that anything that you start with equals itself. The symmetric property tells you that if A equals B, then B equals A. And if you notice, these are like mirror images of each other, right? Everything kind of like mirrored. So A was on the left, it equals B. So now then B equals A. So it doesn't matter if you switch sides on the equal sign, or you flip it, or take a mirror image, however you want to say, it's the same thing. So the symmetric property is used, for example, a lot of times too, like we'll get an equation and we'll end up with 3 equals x, and then we'll rewrite it as x equals 3. And basically the symmetric property is the one that says that that's okay to do. The distributive or the transitive property is the property that follows what we talked about, law of syllogism. Remember, where it basically says if A equals B and B equals C, then A equals C. And so what happens is these middles kind of cancel and we can go straight from beginning to end. Okay. The distributive property is probably the most common one. And we know that when we're multiplying a value like A times an expression, if it's an addition expression, we can make that A times B plus C is equivalent to A times B plus A times C. And if it's a subtraction problem to begin with, then A times B minus A times C is equivalent to this. And so again, distributive is probably one of the most common. I think that's one of the ones that you'll remember the most. Now we're going to use those same properties, but we're going to apply those properties of equality to angles and segments. And so how would we apply the reflexive property to an angle or a segment? Well, remember, the reflexive property says that anything equals itself. So A equals A, and 5 equals 5, and 5x equals 5x. So how does that transfer to a segment, right? Well, it says that segment DE is equal to itself, segment DE. So segment AB is equal to segment AB. And then in angles, we know angle A is going to equal angle A. Angle D equals angle D. So all we're saying is that anything, including segments and angles, are equal to themselves. When it comes to the symmetric property, remember that we switch things around. So in other words, if we have, A equals B, then it becomes B equals A. Or if I say X is 3, that's the same as 3 equals X. And so we're just switching the sides, kind of like mirroring it in a way. And so the symmetric property can apply also to segments, because then I can say that, for example, if segment DE equals FG, then FG equals DE. If segment AB equals CD, then CD equals AB. And all I'm doing is, yes, I can flip them on the equal sign, and it's not going to make a difference. It's still equal or whatever. So the symmetric property applies to segments, and it also applies to angles. So again, if I start and I say that angle A equals angle B, the symmetric property says that angle B equals angle A is the same thing. And again, if angle C equals angle D, then angle D equals angle C. And again, just flip it on the equal sign, but it's just the same exact concept. And the last one is the transitive property of equality. And again, these are all properties of equality. We use the letters POE for short, okay? And so, again, the transitive property, this is, again, if A equals B and B equals C, then I can go straight and say that A equals C. I can cancel out these middle terms. Same goes here. If segment AB equals segment CD and segment CD equals segment EF, I can cancel these middles and I can say that AB is equal to EF. And same goes for angles. If angle A equals angle B and angle B equals angle C, I can cancel these middles and I can say that angle A equals angle C. So again, this is just like syllogism. We learned about it, but it's the transitive property of equality. So in this section, we're going to justify a statement with a property from algebra or a property from congruence. Now, this property of congruence we have not yet covered. We have been focusing on properties of equality. We will talk about properties of congruence, but right now we're going to focus on properties of equality, and again, we can call those POE for short to save time. So this is when we're given properties, or we're given examples of things, and we have to determine what property states that that's true. So in other words, we're given the statement AB equals CD, then CD equals AB. Notice that all that was swapped was the letters from, the left side went to the right side went to the left, and this is the symmetric property of equality. In number 2, we went from 3 times the expression x plus y to the fact that that equals 3 times x plus 3 times y, and this is the distributive property of equality. Wow, I think I totally spelled that wrong. Let me do this a little slower. Distributive property of equality, and we could call it a sum. I mean, I don't really need you to specify if it's a sum or difference, but it is the distributive property, okay? The next one, number 3, it says if 2a plus b equals 24 and b equals 4a, then 2a plus 4a equals 24. And sometimes they can get a little confusing, so let's see what happened. We started with 2a plus b equals 24. Then they told us that b equals 4a, and then notice that in the next one, they substituted 4a for b. In other words, they just swapped it out. They took this 4a and they put it here where the b originally was. So that is a substitution property of equality. Okay. Once you know that b and 4a are equivalent, you can sub them in for each other anytime you want. And then the last one, again, we start out with this statement and we end up with this. And we're like, wow, how did we get from x divided by 3 is 12 to x is 36? And you know, just because you know algebra, that what they did was they multiplied both sides by 3 and they got x is 36. And so the step that they did here is the multiplication property of equality, because notice again, multiplication property of equality says that if you multiply both sides of an equation by the same number, the equation stays balanced. The 3 canceled, the other side became 36. So we're going to give you problems like this where we're going to show you things and we're going to ask you what property of equality was involved in that step. Sometimes it's going to involve segments, sometimes it's going to involve algebra. Same properties, same thing. All right, so we're going to keep going. So here what happens is we're starting with an original equation. So we're starting with a math problem here. Here's an equation, 2/3 x equals 9 minus 4x. And it's ending up down here at the bottom as x equals 27 over 14. And so if you notice, all along the way, they're giving you steps to solve this problem. Things are being done to this equation to get to that solution. So we have to kind of justify and say what was done each time to get from one step to the other. So the original is what's given, and this is how we start every proof. We basically take whatever was given to us at the original equation or the original diagram or original information, and we categorize it as given. Then we consider what happened between step 1 and step 2. And I'm going to kind of look at it and see what the difference is. And I notice what they did, and I see that they multiplied both sides by 3. Notice they did 3 here, and then they did 3 times that. And they ended up with 2x equals 3 times 9 minus 4x. So to get from basically step 1 to 2, what they did was the multiplication property of equality, because they basically had to multiply both sides by 3. So then we go from step 2 to step 3, and again we have to ask ourselves what changed. How did we get from 2 to 3? What was done? And you notice they basically distributed the 3. So I know that this is the distributive property of equality. Okay? That's how they got from 2 to 3. They distributed the 3. Then we ask ourselves, okay, how do they get from step 3 to step 4? So again, I'm looking to see what happened here, and I recognize that what they did was they added 12x to both sides, right? That canceled it on the left, and it made it 14x equals 27. So because they added to both sides the 12x, what they did was they used the addition property of equality. And then I notice in this last step, to get from here to here, they divided both sides by 14. And so that means they did the division property of equality. And so that's it. We got to the answer, and I justified the steps every single time. So that's pretty much kind of how we do a proof. We basically go from one thing to the next to prove our point, and we explain what process we did to get there, or what theorem or what postulate or what definition or what property allows us to make that decision. You know, what allowed us to multiply 3 times 9 minus 3 times 4x? What told us that that would be okay to do? And so we're going to get really good at it, and it's a great place to start with algebra because algebra is easy for you at this point. Now here we're given an equation, and they want us to justify the steps, so we're going to kind of write it out with our little proof, right? We're going to kind of give you an introduction here on how the proof works. We're going to put statements or steps on the left, and we're going to put reasons or justifications on the right. And so again, like always on our proofs, we always want to start with what's been given to us. So in step 1, I'm going to start with the problem that was given. This is the problem that was given to us, and so the reason or the justification for writing that in that step is because it was given. And just like in the last problem where they had the different things, we're going to write those out ourselves. Now, if you noticed in the last problem, when they went from step 1 to step 2, let's just say that the step is to add 4x to both sides. In the last problem, they didn't really show us the adding of the 4x, right? They just kind of wrote it out. They just said, okay, 7x plus 2 is 23. And we sort of had to envision, well, what happened in that step, right? Where did that, how did we get from the given to 7x plus 2 equals 23? So, and yes, the step that was done there, right, is the, we added 4x to both sides, so it's the addition property of equality. Now, the thing is that sometimes people like to write proofs more where they can see the steps. Like they don't like to go from step 1 to 2 without showing that in-between step of adding the 4x. So I'm going to do this one showing you the in-between steps. And those in-between steps are going to lend to a new reason called simplifying. And I'll show you what I mean. So we would basically start with the given. And then in step 2, what we would do is we would have what we had here, 23 minus 4x. But then here we would show our plus 4x and plus 4x. And because we're adding 4x to both sides, we know that this step is going to be the addition property of equality, like that, right? And then step 3 is where we sort of clean it up and we get rid of the extra stuff that we don't need. Like, in other words, we combine these like terms over here. We change it to 7x plus 2. And then over here, it just becomes 23 because those would cancel. And so now to go from 2 to 3, all I really did was clean it up or combine my like terms, which in math, when you combine your like terms, what you're really doing is simplifying your equation. So that's simplify. That's the step that was done to clean it up. And so notice it's just a little bit extra, but some people really like seeing it. So then again, in step 4, now I know that I'm going to subtract 2 from both sides. So I have my 7x plus 2 and my 23, and I'm going to subtract 2 from both sides. And so I know that this is showing the subtraction property of equality. And then in step 5, I'm going to kind of clean it up again. So I'm going to end up with 7x equals 21. And so again, this would be simplifying. Again, if I'm combining like terms, I'm simplifying or simplify, okay? In step 6, I'm going to show, I'm going to basically then, since I want to isolate x, right? I know in this step, I'm going to have to divide both sides by 7 so that I can get to solving this, right? And so since I'm going to be dividing by 7, then this is the division property of equality. And then in step 7, again, I'm going to actually be solving this, right? Like I'm simplifying it. So it's simplify once again. Simplify or simplifying. I guess simplify would be probably the better way to write it. And then notice that I solved it. And so I went from the original to the solution. I went from given to whatever. And I have these intermediary steps. If I had skipped that, right, and done it like the one on the slide before, I would have basically had this, and this. I would have done it in 4 steps. I wouldn't have shown the middle. And then these would have been my 4 properties. Given, it would have been addition, subtraction, and division. And that would have gotten me to the answer, right? It would have ended up like here, there, and there. So it's much shorter if I skip the simplifying phase of it. But the simplifying phase, a lot of people like it because they want to see the steps. They want each thing to show the steps of what was done. It's up to you how you do it. I would take either one. You have to find the way that you like to do proofs better. So again here, we're going to do the same thing. Again, we're going to be given, we're going to create a little toolbar here, a little T-bar. I'm going to have my statements on the left. I'm going to have my reasons on the right. And I'm always going to start with the given. P times R plus 1 equals N. And again, I'm going to put that as given. So step 1 is given. And again, here we have to decide, do we want to do the proof where we have all the intermediate steps, or do we want to just go from one to the next? I'm going to go just from one to the next, right? So I know that I'm going to be dividing both sides by P. And so on the left, I'm going to end up with R plus 1. And on the right, I'm going to end up with N over P. And so because I divided both sides by P, it's going to be division property of equality. And for those of you that want to just see it, I'll just show you. This is not something you would have to write on this slide, but that's what I did. That's how we went from step 1 to step 2, okay? Now, to go from 2 to step 3, I know that if my goal is to solve for r, I have to isolate r, and that means I have to subtract 1 from both sides. And so when I do that, I'm going to be left with this. And so this is the subtraction POE, subtraction property of equality. And again, if you need to see what I did, I subtracted 1 from both sides, and that's how I got that answer. Again, what's in red is not something I would expect you to show me unless you're going to do the one with the simplifying, where that would actually be an additional step, okay? But again, I just want to show you in case, you need to see how did I get from 1 to 2 to 3. And now I solved for r. My problem is done. So now this last one is where we actually start to see a geometric one. And when we see our geometric proof, we are usually going to be given information sometimes in the word problem or in words, and other times we're going to be given information in a diagram. Sometimes we're going to have information in 2 places. So you definitely want to look at your diagrams to identify anything that might be given to you. In this problem, the information that we're given is in the picture. So again, we have our statements, we have our reasons, and we want to start always by what's given to us. And so when I look, what I see here is that angle 1 is congruent to angle 3. So I know that the given information is that the measure of angle 1 equals the measure of angle 3. That's a given piece of information. Now, what do they want me to prove? Notice that my proof, I don't know what step that's going to be, but they want me to prove that the measure of angle DBA is equal to the measure of angle EBC. So first of all, I don't know what reason I'm going to be able to prove that, but notice that I'm given right now my angles in numbers, angle 1, 2, and 3, and I got to somehow swap my numbers for the letters. So sometimes you have to look at the drawing yourself and sort of figure it out in your own head. Notice that DBA is really the measure of angle 2 plus angle 3 together, right? Remember that we learned a postulate that said the sum of the parts is equal to the whole. So I know in number 2, for example, I can introduce the idea of the measure of angle DBA. And I can say angle DBA is equal to the measure of angle 2 plus the measure of angle 3. And to justify that, I would use my angle addition postulate. And the angle addition postulate, we can write for short angle addition postulate. Okay, I'm okay with that. And basically it says that the whole angle is equal to the sum of its parts. And so on that same note, right, I know that I could either start now looking into, for example, EBC. I could try to figure that one out. Or I could continue a little bit and do something that I want to do that I think is going to be helpful to me, okay? If you notice, we know that the measure of angle 1 is equal to the measure of angle 3. So because I know that angle 1 and angle 3 are equal, I know that I could rewrite the step in number 2. I could rewrite this and I could say that the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 1. Notice that I substituted angle 1 for angle 3 because again, up here, I already stated that they were equal. Okay, I can't substitute something in a proof unless somewhere in the proof I've already told you that they're equal to each other. Once I tell you that they're equal, now I can use the substitution property of equality. So again, here I'm now going to say that this was acceptable and this is an okay thing to do because the substitution property of equality says I can do that. So now I have angle DBA in terms of measure of angle 2 and angle 1. Well, now let's look at angle 2 and angle 1. If I take angle 2 and 1 together, notice that they're equivalent to angle EBC, right? And remember that angle EBC is this one here that I'm trying to find, right? So again, I could say that the measure of angle 2 plus the measure of angle 1 equals the measure of angle EBC. And the reason I can justify that, right, is again the angle addition postulate. I know that the sum of those two angles, angle addition postulate, or AAP, I know that the sum of those two angles has to equal angle 1 plus angle 2. So now that I have that, notice that what I need to get to is this last step here. I need to get to the fact that the measure of angle DBA is equal to the measure of EBC. Well, look at step 3 and 4. Remember that we learned about the transitive property. Remember we learned that if the measure of DBA equals angle 2 plus angle 1 and angle 2 plus angle 1 equals the measure of EBC, then I could cancel these middles and I can go straight from here to here. And so the transitive property says that I can say that the measure of DBA is equal to the measure of EBC. And so this was one way that I could write this, and it would be using the transitive property. Wow, that's just I don't even know what I wrote there, but it is the transitive, oh well, I did it again, property of equality. Now, I could have used a different one as well. What I could have also done instead of 5, in place of it, what I could have done is notice that this and this are the same. And so if angle 2 plus angle 1 is equal to EBC, I could have just substituted EBC for this. So I could have said measure of angle DBA equals the measure of angle EBC, and I could have said that it was substitution. Okay, now I prefer transitive, but I would have taken substitution because, again, it's valid as well. So either one would have worked as the justification. And that's what I'm telling you about, how there's different ways to get to the same thing. And so I will always walk through your proof and see if it makes sense logically, if you used the properties correctly. And if you did, I'm going to give you credit. Even if I would have done transitive versus substitution, they're both valid justifications for step 5. Now, this gives you an introduction into kind of how we prove things and proofs, and we're going to be doing proofs for several months, and you're going to get much, much better at them as time goes by. Just kind of look at what I've done here and walk through it and see if it's starting to make some sense to you. We will do so many practice problems, believe me, it will begin to make sense as you go. Some of you will get it sooner, some of you will get it later, but you'll all get it.